The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we start the final chapter this quarter, and we're going to look at section 11.1. And first of all, I want to review how we deal with function notation and how things work. Let's say we have the following function. Let's see, how about this? F of x equals 2x plus 1. And let's say that g of x equals x squared minus 1. All right, so let's go back here and look at this f of x equals 2x plus 1. What if I wanted to find f of 0? What would I do? I'd put 0 in the place of x, and I'd have 2 times 0 plus 1, which is 1. So f of 0 equals 1. What if I had f of negative 3? I'd have 2 times negative 3 plus 1, which is negative 6 plus 1, which is negative 5. So f of negative 3 equals negative 5. What if I had f of star? That would be 2 star plus 1. What if I had f of 2x? Then I would put 2x in the place of x in the original function, which would then give me 4x plus 1. So f of 2x equals 4x plus 1. What if I had f of x squared minus 1? Then I would put x squared minus 1 in the place of x in the original function. So I'd have 2 times the quantity x squared minus 1 plus 1, which would be 2x squared minus 2 plus 1, or 2x squared minus 1. So f of x squared minus 1 equals 2x squared minus 1. Well, let's go back and let's revisit these two functions. F of x equals 2x plus 1, and g of x equals x squared minus 1. Is that right? Yeah, okay. We're going to look at something called composition of functions. Composition is an operation, kind of like multiplication, division, addition, subtraction, okay? And composition looks like this. It's a little circle. So we're going to take f composed with g of x. And I know it looks like fog, and some of you may feel like you're in a fog, but that little circle means composition. Well, f composed with g of x is equal to f of g of x. So basically, we are evaluating a function at another function, okay? So f composed with g of x is equal to f of g of x. Well, what is that equal to? Well, that's equal to f of, but g of x is this, so we're going to put that in here. So we're going to get f of 2x minus 1. Well, what are we going to do with that? We're going to take 2x squared minus 1 and put it in here. So that's equal to 2 times x squared minus 1 plus 1, which is 2x squared minus 2 plus 1, or 2x squared minus 1. You'll notice that's the same problem we did earlier, only now we're dealing with it in terms of composition of functions. So f composed with g of x equals f of g of x equals f of x squared minus 1, and ultimately we get it's equal to 2x squared minus 1. Well, let's go back and let's use these same two functions again. Only now, let's reverse the role. Let's take g composed with f of x. So that is equal to g of f of x. But that's equal to g of, let's see, f of x, that's this, so that's going to go in there. So that's going to be g of 2x plus 1. And then that's going to go in there. So that's equal to 2x plus 1, the quantity squared, minus 1. Remember, all of this replaces x in the g of x function. Well, that's equal to 2x plus 1 times 2x plus 1 minus 1, which is 4x squared plus 2x plus 2x plus 1 minus 1, which is 4x squared plus 4x. And then the minus 1 plus 1 cancels. So g composed with f of x equals 4x squared plus 4x. All right, so let's go back and let's look at some more specific examples using just numbers. And let's say we've got the following. We have, let's see here. We've got f of x equals 3x minus 2, and g of x equals x squared plus x. It says find each of the following. Let's find f composed with g of 4. So now f composed with g of 4 is equal to f of g of 4. Well, let's see. What is g of 4? G of 4 would be 4 squared plus 4, which is 16, plus 4, which is 20. So that's going to go in the place of g of 4, and we have f of 20. But what is f of 20? Well, we're going to take that and put it in there. So we're going to get 3 times 20 minus 2, 60 minus 2, which is 58. Now, there's nothing really complicated here. It's just that you've got to get things in the correct order. F composed with g of 4, we start on the inside g of 4, we get that value, and then we take f of that value, okay? So order is very important here, all right? Using those same two functions, f of x equals 3x minus 2, and g of x equals x squared plus x. Let's find, let's see here, how about g composed with f of 0? That would be equal to g of f of 0. Well, taking this, f of 0 is 3 times 0 minus 2, which is negative 2. So that's going to go in there. So now we've got g of negative 2. That's going to go in here. So that's negative 2, the quantity squared, plus negative 2, which is 4 minus 2, which is 2. So again, you're evaluating from the inside out. Okay, let's see here. How about this one? Let f of x equal 1 over x and g of x equal 1 over x squared. Find each of the following. G composed with f of 1/3. G composed with f of 1/3 equals g of f of 1/3, which is g of, well, let's see, we need to figure out what f of 1/3 is. F of 1/3 is 1 over 1/3, which is 1 divided by 1/3, which is 1 times 3 over 1, which is 3. So that goes in here. So now we're going to find g of 3, which is 1 over 3 squared, or 1/9. So g composed with f of 1/3 equals 1/9. for this given set of functions, f of x and g of x. Let's see, let's take a look at this one. Again, we're going to let f of x equal 1 over x and g of x equal 1 over x squared. We're going to find g composed with f of 8x. So that's equal to g of f of 8x, which is equal to g of, well, let's see, what is f of 8x? F of 8x would be 1 over 8x. Okay, because again, we put 8x in the place of x. That's going to go in here. Okay, and that's equal to 1 over x squared, which is 1 over 8x squared, which is 1 over 64x squared, squaring this and this, which is 1 divided by 1 over 64x squared, which is 1 times 64x squared over 1, which is 64x squared. Okay, let's see here. How about this? Let's say let h of t equal the square root of t plus 3 and k of t equals t minus 5. Okay. Let's find h composed with k of 18. That's equal to h of k of 18, which is equal to h of, well, let's see, what is k of 18? K of 18 would be 18 minus 5, which is 13. And h of 13 is the square root of 13 plus 3, which is the square root of 16, which is 4. Okay, so that came out nicely. Let's take a look at another example where again we're going to let h of t equal the square root of t plus 3 and k of t is going to equal t minus 5. Let's find k composed with h of 22. Well, that's equal to k of h of 22, which is equal to k of, well, let's see, what is h of 22? That's the square root of 22 plus 3, which is the square root of 25, which is 5. So that's going to go in here. And k of 5 is 5 minus 5, which is 0. So k composed with h of 22 equals 0. All right, now multiplication is commutative. 7 times 3 equals 3 times 7. Addition is commutative. 7 plus 3 equals 3 plus 7. What about composition? Is composition commutative? Well, let's take a couple of functions and see what we get. So we're going to take f of x equals x plus 1 and g of x equals 2x minus 5. So the question is f composed with g of x equal to g composed with f of x? So first of all, let's find f composed with g of x. So that's equal to f of g of x, which is f of 2x minus 5, which is 2x minus 5 plus 1, or 2x. Hang on a second here. I'm going to write this. That's equal to 2x minus 5 plus 1, which is equal to 2x minus 4, because I want to have some room here. All right, so f composed with g of x is 2x minus 4. All right, now let's take g composed with f of x. That's equal to g of f of x, which is equal to g of what? X plus 1, which is equal to 2 times the quantity x plus 1 minus 5, 2x plus 2 minus 5, 2x minus 3. And these are not equal. Now, there is a case where composition of functions are commutative, and that is when the functions are inverses of each other. And we're going to talk about that tomorrow. But before we do that, I'm going to do another example here. I'm going to go in and pause the recording for a minute. Okay, let's take a look at some graphs. We have the red graph, which is the graph of f, and the blue graph, which is the graph of g. Using the graphs rather than their actual function representation, we're going to find f composed with g of 3. Well, f composed with g of 3 is equal to f of g of 3. So I need to figure out what g of 3 is. Well, looking at the blue graph, the g function graph, when the input is 3, what is the output? -3. So since g of 3 equals -3, that's going to go in here. Okay. Now we're going to find f of -3. Well, f of -3 is 1. All righty. Let's take a look at another example. So hold on. All right. Here's another example. We're going to find g composed with f of 2. Again, using the same f and g functions. So this is equal to g of f of 2. Well, let's see. F of 2. So when the input is 2, the output is 3. So that's going to go over there. So we're going to have g of 3. And when the input is 3, the output is -3. So again, we do the same thing, but we get values off the graph instead of just plugging them into the original functions. All right, well, that's all I've got for today. A couple of things, if I didn't mention already, this Thursday, I will not be available during the office hour. I have a department chair meeting. And Saturday and Sunday, I will be up in the woods, so I will not be responding to questions or requests over the weekend, but I will be back Monday. Monday is a holiday, but I will be looking at emails from students. Anyway, hope you have a great rest of the day, and I will be back at 1:15. Bye now.